My name is Hadi Farhangi on Basics of Statistics, Introduction to Hypothesis Testing. Topics of this video: reminder of normal and t-student distributions, definitions related to hypothesis testing, rationale behind hypothesis testing, and p-values and hypothesis testing. Next topic is standard normal distribution. It is bell-shaped with the mean of 0 and variance of 1. Here's you see it in the figure. It is bell-shaped and it is symmetric. That means probability of z greater than equal to x is equal to probability of z less than equal to minus x. For calculating the probability in Google Sheet, we use norm.dist x011. So probability of z less than equal to x is being calculated by this function. Here's the example. Calculate probability of z greater than equal to 2. Answer: probability of z greater than 2 is the same as probability of z less than minus 2 based on symmetric property, which we write it using norm.dist x011 instead of x minus 2, and the Google Sheet will return 0.0228. Next, t-student distribution. Here's the t compared to the standard normal. T is in green. It is shorter and fatter on the tails, while z variable is taller and it is shown in red. Both have the mean of 0. If x has a t distribution with the degree of freedom equal to nu, which is n-1, one can show it by x is t nu. Symmetric property of the t distribution is the same, similar to the standard normal. Probability of t greater than equal to x is same as probability of t less than equal to minus x. Calculating probabilities of t distribution using Google Sheet, probability of t less than equal to x with the degree of freedom of nu is equal to t.dist x nu1. Example: what is the probability of t less than equal to minus 2 if nu is equal to 7? The answer: t.dist x nu1, x is minus 2, nu is 7, and the Google Sheet will return 0.0428. Another example: calculate probability of t greater than 3 with the degree of freedom 16. The answer, based on symmetric property, is the same as probability of t less than equal to minus 3 with the degree of freedom 16, which is t.dist minus 3, 16, and 1, which is 0.0042. Next topic: definitions in hypothesis testing. Hypothesis testing investigates the claims about variables. Such claims can be as follows: the mean of a variable is increased, decreased, or changed. The mean of variable is greater, smaller, different than another variable. The variance of variable is increased, decreased, changed, etc. Definition: hypothesis testing is a process to test a claim and it concludes with either rejecting a claim or accepting it. Note that the claim is shown with HA, alternative hypothesis, and its logical opposite is shown with H0, null hypothesis. In every hypothesis testing, one should state H0 and HA first, which dictates the setting and shows how to proceed with the testing. More on definition. Example: for following claims, state the setting of hypothesis testing by finding the null and alternative hypotheses. A, the average number of students with a business degree graduating in 2023 is greater than 300. Answer. The claim is that the average mu is greater than 300. The claim gives the alternative hypothesis. This means HA is mu greater than 300. The logical opposite of mu greater than 300 is mu less than equal to 300, which is the null hypothesis. That means H0 is mu less than equal to 300. Here's the setting. HA mu less than equal to 300 and HA mu greater than 300. Again, HA is the claim, H0 is logical opposite of the claim. B, the average of customers in a McDonald's drive-thru is different than 500 per day. The answer, the claim is that the average is different than 500. The claim gives the alternative hypothesis. This means HA is mu not equal to 500. The logical opposite of that is mu equal to 500, which is the null hypothesis. So the setting of hypothesis is that H0 mu 500 and HA mu not equal to 500. C, the percentage of honest reporters in the legacy media is less than 1%. So we have to state the null and alternative hypothesis for that. The claim is on the percentage, and it says the percentage is less than 1%. The claims gives the alternative hypothesis. This means HA is P less than 1%. The logical opposite of P less than 1% is P greater than equal to 1%, which is the null hypothesis. So H0 is P greater than equal to 1%. So the setting of hypothesis is that H0 P greater than equal to 1%. An alternative is HA P less than 1%. More on hypothesis testing, rationale. If the claim is true, then the parameter, as stated in H0, should not belong to the confidence interval on the claim. So one should construct a confidence interval for the parameter that is based on HA to accept the claim if the interval and H0 do not intersect, or reject the claim if they do indeed intersect. Note that the testing a claim should only proceed if there is evidence to support the claim. For example, if the claim is mu less than 20 and the evidence is x bar 21, then there is no evidence to proceed since x bar is greater than 20. Only if x bar was less than 20, one should proceed with hypothesis testing. Here's an example. Assume a swimmer 100-yard record is 40 seconds and company introduces new swimming suit and claims it reduces the swimming time. The swimmer wears it and completes 16 swims with the average time of 39 seconds. Assume the swimming times are normally distributed with a standard deviation of 2 seconds. Investigate the claim with 90% confidence level. Here's the answer. First, find the setting of hypothesis testing. The claim is the average time reduces. This means HA is mu less than 40. The logical opposite of that is H0 mu greater than equal to 40. This gives the setting H0 mu greater than equal to 40 and HA mu less than 40. Now construct the confidence interval based on HA, which is left tail confidence interval. And the confidence level is 90%, which means 1 minus alpha is 0.9, which gives alpha is 0.1 or 10%. Z alpha of 10% is 1.28 if you use Google Sheet, and according to the question, sigma is 2, x bar 39, and n is equal to 16. The left tail confidence interval will be constructed as mu less than equal x bar plus z alpha sigma over a square root of n. We have x bar, we have z alpha, we have sigma, we have n. If you plug in all these numbers, it will be everything less than 39.609. Let's compare this confidence interval with H0 and see if they intersect. Confidence interval is mu less than equal to 39.68 and H0 is mu greater than 40. Obviously, they do not intersect. This means one should accept the claim or reject the null hypothesis. Accepting the claim means that based on data, the new swimsuit reduces swimming time. More on hypothesis testing p-values. It is customary to compute p-value and compare it to alpha when performing hypothesis testing. Let's assume that one claims that the mean of a normal variable is greater than 10, and it should be tested to either accept the claim or reject it. The setting of hypothesis as follows: H0 mu less than equal to 10 and HA mu greater than 10. The confidence interval based on HA is x bar minus z alpha sigma over square root of n less than equal to mu. Based on the definition of confidence interval, one can say probability of mu belonging to this confidence interval is greater than equal to 1 minus alpha. If you find its opposite, it's complementary, then probability of mu less than x bar minus z alpha sigma over square root of n, that probability is less than alpha. If you continue computing, you will get the p-value as probability of z less than x bar minus mu over sigma over square root of n. According to previous calculation, if p-value is less than alpha, then the interval does not intersect with each zero and we accept the claim. Otherwise, one should reject the claim. It means the calculation of p-value and creating confidence intervals is the same. Given this, the split of hypothesis testing using p-value R, step 1, state the setting of hypothesis. Claim gives H0 and its logical opposite H0. Calculate p-value. It is probability of being outside the confidence interval. It depends on the distribution, type of this, etc. If p-value is less than alpha, one should accept the claim. Otherwise, reject the claim. And of course, accepting the claim means rejecting the null hypothesis, and rejecting the claim, failing to reject the null hypothesis.